Okay, this should be the last one of these on the chi-square. I think we can wrap everything up. Before we get started on the previously recorded information, let me go over a couple of things with you right quick. First, the assumptions of the chi-square test. And there are a variety of these that we'll be dealing with. The assumptions are given to us here. The sample or the observed values are randomly selected and they're categorized into frequency counts. Now, I do want to make a point here that happens a lot of times is that someone will go through and they'll collect data, interval type of data or ratio type data, maybe age or something like that, and then they'll go through and break it down into different categories. They may take and break it down into the categories of 10 to 20 or 21 to 30 or something like that. And I really am not a big fan of that. So if you go through and you actually collect data like the age of people, 10, 15, 19, 37, 28, whatever, and then you come back and you put those into these categories, 10 to 19, 20 to 29, 30 to 39, etc., whatever. The problem is that you're going through and you're losing data. You're combining it into these categories when you could use the actual data up here. And so I'm not a big proponent of that, and I would suggest that you don't do that. But you will see that sometimes in the literature people have done that in a study. So anyway, the sample, the data has been randomly selected and categorized into frequency counts. It's especially useful if it's yes, no, or something like that. The null hypothesis is that the row and the column variables are independent, and the alternative hypothesis is that they are dependent. So you're saying that there's no relationship between them as a null hypothesis. And then the expected value for each cell is at least 5. And I'm going to make a few more comments on that in the video. So let me just go ahead and pick up at that point. Chi-square is that we have to make sure that there are no expected values less than 5. Okay? Now, we're not saying observed. Okay? We're not saying observed here. We're saying expected values. So if we were to have a table that might be something like this, you could have 3 and 10 and 15 and say 2. So this is 13 and 17. This is 12 and 18. So the expected value for this cell would be 13 times 18 divided by 30. And I didn't bring a calculator with me to do all of that. But let's see, 6, 10, 3, 5. So that's going to be about 39 over 5. So the expected value in this cell is going to be 8. So it's okay. Expected value is going to be somewhere around 8 there. You can have an observed value less than 5, but you can't have an expected value less than 5. So watch out for that when you go through and do your calculations. The chi-square calculation is so critical. You use that in a lot of tests. Again, we've talked about this table in previous videos. Chi-square is here, chi-square or contingency tables here, here. Almost anything that has nominal data is going to use a chi-square table. Whether you're doing one group, two hypothetical, two independent groups, two paired measurements, three or more matched groups, you're going to use it. So hopefully this has been helpful to you, and have a good day. Again, let me come back before you leave on me. Chi-square is one of those tests that's used a lot. If you go through and look at the literature, you'll see that it is in a lot of the literature. Let me go back to the table that we were looking at previously, and you can see that it is here. Chi-square is here, and then we've got McNemar's test, which is also covered in this chapter. McNemar's test is used if you have paired data. For example, you do a lotion type of treatment on one hand and a lotion type of treatment on the other hand, and then you come back and you say which one is better. That'd be McNemar's is two measurements taken on the same person. And then contingency tables, chi-square tables, contingency coefficient. A lot of the terms that we'll see in this, we've talked about the goodness of fit. We've talked about the test of independence, the test of homogeneity. Once you get into the chapter, start reading it. But you see it's the same thing over and over and over again on the chi-square table, is that the calculations are all boiled down to that same formula that we've used, and that's going to be the sum of the observed minus the expected squared over the expected. And as long as we have this expected value that's greater than 5, then we're in good shape. So a lot of different things you can do with the chi-square table. So I'm going to end at this point, and so again, I hope that you're having a